Let's start our discussion from Software Testing Fundamentals. Software engineer develops a product based upon the concepts he has developed after customer communication and observation of the existing system. After a software product is developed, it is tested before delivering to the customer. In order to test a software product, software engineer develops test cases. During testing, the system is manipulated by giving different types of input and checking whether the tests can diagnose all types of errors. Moreover, it is checked whether the system is properly functioning and providing accurate results. It is also ensured that different parts of the system are properly integrated. Thus, we can say that the objectives of testing are to find errors in the software developed. Testing should be done in such a way that it reveals undiscovered errors in a minimum amount of time. To check that working of the software functions is according to the specifications. Their behavior and performance requirements are being fulfilled. To check the reliability and quality of software. Discuss testing principles. Before developing test cases, a software engineer must understand the testing principles. Some important testing principles are: tests should be designed in such a way that they identify errors in the system related to customer requirements. Test planning should begin as soon as the requirements model is complete. Detailed definition of test cases can be made after the design model is complete. Experience shows that errors are repetitive. Generally, if 20% of the program module is properly checked, then 80% of the errors are identified, which repeat throughout the program. Testing should be applied to individual components first, then to integrated clusters of components, and finally to the entire system. Program logic should be properly checked, and it should be ensured that all conditions in the component level design have been exercised. To be most effective, testing may be conducted by an independent third party that is competent and is unaware of the development stages. Test case design. Test case design is an important activity in software engineering and should be done very carefully so that a test case should be complete and it must possess the highest probability of finding errors with the minimum amount of time and effort. There are different methods to develop a test case. These methods provide the developer with a systematic approach to testing. These methods also provide a mechanism that can help to ensure the completeness of tests and provide the highest likelihood of uncovering errors in software. Any software can be tested in one of two ways. Number 1. Knowing the specified function that a product has been designed to perform, tests can be conducted that demonstrate each function is fully operational while at the same time searching for errors in each function. Number 2. Knowing the internal workings of a product, tests can be conducted to ensure that internal operations are performed according to specifications and all internal components have been adequately exercised. The first test approach is called black box testing and the second white box testing. Since white box testing requires exhaustive testing, therefore mostly white box testing is preferred. Let's discuss these types of methodologies in detail. Black box testing is to test the functionality of the system. For example, when black box testing is applied to software engineering, the tester would only know the valid inputs and what the expected outputs should be, but not how the program actually arrives at those outputs. It is because of this that black box testing can be considered testing with respect to the specifications. No other knowledge of the program is necessary. Black box testing focuses on the functional requirements of the software. That is, black box testing enables the software engineer to derive sets of input conditions that will fully exercise all functional requirements for a program. Black box testing attempts to find errors in the following categories. Number 1. Incorrect or missing functions. Number 2. Interface errors. Number 3. Errors in data structures or external database access. Number 4. Behavior or performance errors. Number 5. Initialization and termination errors. Let's discuss these types of errors. Incorrect or missing function may include error due to missing some function. For example, missing printing function. Now we will discuss second type of testing technique, that is white box testing. White box testing is the process of testing the internal operations performed by the system so as to ensure that all the requirements are fulfilled. Using white box testing method, test cases are derived that ensure that all independent paths within a module have been exercised at least once. Check all logical decisions on their true and false sides. Execute all loops at their boundaries and within their operational bounds. Exercise internal data structures to ensure their validity. Importance of white box testing is that basis path testing is a white box testing technique first proposed by Tom McCabe. The basis path method enables the test case designer to derive a logical complexity measure of a procedural design and use this measure as a guide for defining a basis set of execution paths. Test cases derived based on basis path technique execute every statement in the program at least once. To understand basis path testing, we must have an idea of flow graph notation, cyclomatic complexity, graph matrices, and derivation of test cases. Structure testing. Control structure testing is a group of white box testing methods. It includes condition testing, data flow testing, and loop testing. Condition testing focuses on exercising the logical conditions in a program module. Errors in condition can be due to Boolean operator error is due to misuse of and, or, and not operators. For example, instead of using and, you use or operator, the result would be different. Boolean variable error can be due to incorrect usage of any Boolean variable. For example, we want to write B1 or B3, but we write B2 or B3. Here, B2 is incorrect. The result would change due to wrong use of Boolean variable. Boolean parentheses error. For example, we want to write the expression shown on the screen where first OR operator is checked and then AND operator is checked. The situation would be different if we write the expression like this. The expression would be as appearing on screen, but if we write it as shown, it would be incorrect. Relational operator error. This may be due to incorrect use of the operators less than equal to, not equal to, greater than equal to. Arithmetic expression error. For example, we want to add two values and then multiply the result with a third value. Our expression should be variable number 1 plus variable number 2 followed by parentheses and then multiplied with variable number 3. If we write this expression without parentheses, then the result would be different. Structure testing. Data flow testing. Select test path according to the location of definitions and use of variables. This technique is actually used to test the variable. It starts from the definition of variable and traces the path where it is used. Mostly it is used in if-else statement. Dear learners, our last topic is loop testing. Loops are fundamental to many algorithms and need thorough testing. There are 4 different classes of loops: simple, concatenated, nested, and unstructured. The strategy is to create a set of tests that force the following situations. Simple loop, skip loop entirely, only one pass through loop, 2 passes through loop, passes less than maximum number of allowed passes through loop, passes greater than or equal to allowed number of passes through the loop. Nested loops. Start with inner loop, set all other loops to minimum values. Conduct simple loop testing on inner loop. Work outward. Continue until all loops tested. Concatenated loops. If independent loops, use simple loop testing. If dependent, treat as nested loops. Unstructured loops. Such type of loops should be redesigned to reflect the use of structured programming constructs.